Hi Year 12. We are looking at the next topic in our Cambridge textbook, which relates to 2E. It's called Using Graphs to Solve Equations and Inequations. Okay, you've had a little go at this before. It's kind of a simultaneous equation really, which is you're quite familiar with. So basically, because we're using graphs, a lot of this is going to be involving us drawing graphs. So we need to be fairly accurate. We want to be a little bit more detailed than a sketch in this one so we can really find where the points cross. So I'm going to jump straight into an example for you. Okay, and then we'll see how we go. So our first example, we are going to be looking at y equals the absolute value of 2 minus x. So you need to throw your memories back to your Year 11 work with our absolute values. We're going to work through that and hopefully in the end solve this inequality down the bottom here. That is our plan. So I popped a Cartesian plane in there for me to use. You'll probably need a ruler and just mark off your intervals for your numbers for this graph, just so that it's a little bit neater. And because we're looking at intersections, we want to be able to read that. Okay, so in order for us to first of all draw this graph, y equals the absolute value of 2 minus x, we really need to figure out where it cuts the x-axis and where it cuts the y-axis. So I've started that down here for us down the bottom. So I've written down there A. We want to find where it cuts the x-axis, and that's going to happen when y is equal to 0, and where it cuts the y-axis is going to happen at x equals 0. So let's do our first one. Cutting the x-axis at y equals 0. 0 is going to be the absolute value of 2 minus x. When is that going to be 0? Well, that's going to be 0 when x is equal to 2. Okay. Where does it cut the y-axis? It cuts the y-axis as x equals 0. So y is going to be 2 minus 0. So again, y is equal to 2. So if you go and have a look at our graph, I've popped those two on there. Here and here. Remembering what an absolute value graph does, this is basically the line minus x plus 2. So this line here. But our minus part has been cut off from the bottom and flipped up here. So we're going to get a great big V shape. So we're not going to have diagrams, parts of our function down below the line. So you can think of this as transformation from last year. So it's minus x plus 2. So here's our line. We've flipped it up. Or it's the line y equals minus x. Or I guess y equals the absolute value of x. And we've actually moved to the right 2 places. So a few different ways to think of it. Let's look at drawing that graph in there now. Again, if you've got a ruler handy, please do that. Okay, that's our first solution for A. Let's have a look at B. So B is wanting us to write down the equation of the right hand and left hand branches of our absolute value. So the left hand branch of our inequality, but absolute value is this line here, and our right hand branch is this part here. So in order to think what's happening there, you need to think about what's happening when we have an inequality. Sorry, not inequality, I keep saying inequality. When we have an absolute value, our absolute value symbols are taking away the negative. Okay, so we're basically getting a line and it's flipping up, so everything happens in the positive section of the y-axis. So if we didn't have that absolute value in there, we would have part of our graph that would also be negative. So we need to also always take into account positive and negative values when we're looking at the absolute value of x. So that's what we're going to use to figure out what our left and right hand branches are. So when we are looking at our absolute values, we always have a positive and a negative solution. So we would have y is equal to 2 minus x. We'd also have y is equal to minus 2 minus x. So I'm going to leave this as 2 minus x because we can't simplify this one. But if I have a look at this one over here, I end up with y is equal to minus 2 plus x. And let's just neaten that up a little bit. Y equals x minus 2. And we might write this one another way as well. Let's get the x out the front for the other one. Minus x plus 2. So let's just highlight those so we can see them nice and easy. So they're the two possible solutions for our absolute value up here. Okay, so I've got a positive one up here. I've got a negative one. And each one of these solutions that we've simplified to the ones in the blue line are a branch of the arm of our diagram here. So one's the left and one's the right. We've just got to figure out which one is which. So let's have a look at this one over here. Y equals minus x plus 2. So minus means it's sloping in the negative direction, and we've moved up 2. So that's going to be this part. This is going to be the left-hand side. So we've got minus x. We've moved up 2. So that's our left-hand side branch. And this was our right-hand side, this one here. Y equals x plus 2. Positive gradient, sorry, y equals x minus 2. Positive gradient, and it's just y equals x slid down 2. So if I did continue this line here, okay, which is what it's representing, okay, moved it down 2, it would cut at minus 2. So that's what that one is, okay. Let's actually write that up there. So, oops, sorry, that's our right-hand side. So our right-hand side line is actually x minus 2, and our left-hand side is minus x plus 2. So that's really what's happening. We haven't really thought of it like that before in our Year 11 work, but that's what actually is happening. Let's have a look at C. It says, on the same diagram, draw the graph of y equals a half x plus 1. Okay, so let's just redraw that equation a little bit. Or you can leave it as y equals a half x plus 1, or you might like to write it as, if I open up the brackets, x over 2 plus a half. I don't mind, but we need to plot that up here, okay? So we need to figure out some points. So maybe what we will do is, if we have a look at some values, let's say we look at x equals 0 first, and we'll actually try and plot that up there. So when x is 0, what have we got y equal? That will be 0 on 2 plus a half, which is a half. So when x is 0, y is a half. So we're over here. And we'll put some other values in there. We'll just go x is 1. Probably should have done a table of values, so that would have been a little bit easier. So when x is 1, y is equal to a half plus a half, which is 1. So when x is 1, y is 1. So we're up here. So I've got 2 points. We might just do another one. When x is 2, y is equal to 2 over 2 plus a half, which is 1 plus a half, which is 1.5. So when x is 2, we've got 1.5. So we've got a line in there that we can draw. Okay, so we've done the first 3. Now we want to find D, the points of intersection. So the points of intersection are the points of intersection between our original function and our new function. And those are going to be one point there, if you have a look in the diagram, and another point here. We can call those P and Q. So there are our points of intersection, P and Q. Okay, so I've got P and Q on there. We need values for P and Q. Because we've hand drawn our graph, we can't very easily read off values for P and Q. If it was a beautifully drawn graph on, drawn say on Desmos, so you could jump on a Desmos and have a look where those points are. However, let's see if we can use some algebra to solve what they are going to be. So let's have a look at that. So we'll pop this down here. We'll pop D in and see what we can do. So we need to solve them separate. So let's look at solving for P first. Finding P. So what is P the intersection of? So P is the intersection of y equals a half x plus 1. Okay, this is a simultaneous equation. And it's also the intersection of the left-hand side of our absolute value, which was y equals minus x plus 2. Or you can write it as 2 minus x. So let's pop those together and solve them simultaneously. So I've got a half x plus 1 is equal to minus x plus 2. Let's open our brackets. We're going to get x on 2 plus a half is equal to minus x plus 2. I'm going to add x to both sides. So I'm going to get x on 2 plus x. I'm going to take away a half from both sides, so I get 2 minus a half. Again, if you need to stop the video and make sure that you're happy with this yourself, please do so. So left-hand side, now I've got x on 2 plus another x, so half x plus 1x gives me 1.5 x's, or 3x on 2. Right-hand side, 2 minus a half is 1.5, which I'm going to also write as 3 on 2, so that we don't have it as a decimal. We'll just leave it as fractions. So what are we going to get? We're going to multiply both sides by 2. So we're going to end up with 6x equals 6, or x is equal to 1. Let's find our y value that corresponds with that. Y is going to be equal to, let's pop it into this one, minus 1 plus 2, which is 1. There's our first point of intersection, 1, 1. Does that look about right? Well, I think we were pretty close with our graph here. It does look about 1, 1. So we would have gone a little bit over 1. So that looks pretty good. Okay, let's find our next point. Let's find Q. So we've still got our line y equals a half x plus 1, but we're looking now at finding the solution with the right-hand side of our absolute value. And the right-hand side was y equals x minus 2. So let's solve that. We've got a half x plus 1 equals x minus 2. Let's open our brackets. X over 2 plus a half equals x minus 2. I might go and we'll take x from both sides. We'll take a half from both sides. So x over 2 minus x is going to be equal to minus 2 minus a half. Let's neaten that up and get our next line. So what we get there is x over 2 minus x, which is half minus 1. We'll end up with minus a half x is equal to minus 2 minus a half. Again, if you get stuck, chuck them in your calculator. That's minus 5 on 2. Multiply both sides by 2. You're going to end up with minus 2x is equal to minus 10, or x is equal to 5. If x equals 5, what's y equal? Y equals 5 minus 2, which is 3. Let's have a look. Does it match what we had up here? 5 and 3. Oh, sort of, a little bit. We're not great with those diagrams. But our answers are correct. If you pop them into Desmos, you'll get those two solutions that we've got down there. So we've done. Okay, so let's have a look at E and F. E says to solve this equation here. Now we have done that. We've actually solved that. That was our point P and Q from before. So let's just write it out a little bit neater. Okay, so we've found the solution. We've found the points of intersection. And the two solutions were 1, 1 that we found down here. And our other solution was 5, 3. Okay, so we're nearly there. Let's look at the last one. We're looking at where the absolute value of 2 minus x is greater than or equal to 1/2 of x plus 1. So go and have a look at the graph. See if you can see what's happening and where one is greater than the other. So have a think what that's actually saying. It's asking us, when is our absolute value of 2 minus x, which is that black curve, when is that greater than or equal to our green line here? Okay, so when it's greater than or equal to, it means it's above it. So when is that black line above the green line? So the black line is above the green line from Q onwards and from P in the negative direction. So we've got two places where that actually happens. So let's pop F down there and we'll write those values in there. Okay, so again, let's have a look. We're looking at when our absolute value of 2 minus x is greater than our half of x minus 1. So we're looking at when our black line is above the green line. So at Q, remember Q, actually better put our points here. There's P, that's Q. So for values of Q, where x is 5, which is here, values of x equal to 5 and above, that happens. X is greater than or equal to 5. And also at P, and our P was 1, 1, so an x is 1. So values of x equal to 1 and less than 1. Oops. So when x, sorry, my stylus is mucking up at the moment. X is less than or equal to 1. Okay, and that's question, the example done, guys, A through to F. Go into textbooks, have a go to E. You will need to draw the graphs. You just need to take your time and realize that when you're drawing an absolute value function, you've got two arms, you've got a left and a right, and if you do that, you should be fine. Otherwise, come back to the video and have a go, ask questions, and come and see me in class if you need some more help.